Okay, so today's topic is potential drop per unit length. See, this topic is very important before we start potentiometer because if you can only solve questions of potentiometer when this topic, that is VCM, is very clear to you. So try to understand this topic and try to write down all the equations, all the numericals that I will discuss in this slide. Okay, so what is potential drop per unit length? So that we have a wire, suppose we have a wire of resistance R and length L. So we have a wire of resistance R and length L and current I is flowing through it. So potential drop in this wire will be I into R. Due to Ohm's law, V will be equal to I into R. Now VCM is basically potential drop per unit length. That is potential drop divided by length. So what is potential drop V? What is length L? Now, if I have written VCM, it means I am taking length in centimeter. So you have to take the length in centimeter. So potential drop is V, length is L. So VCM is basically potential drop divided by length. So L will be in centimeter and unit of VCM will be V upon CM. Okay. Now also, for your understanding purpose, we can replace this wire of length L with a battery. So we can replace this wire of length L with a battery of potential V, and V will be equal to VCM into L. So V will be equal to, if L will go on that side, that VCM into L. So we can replace a wire in which potential drop is V with a battery just for your understanding purpose. And where will we put the positive terminal? From the side from which current is coming. So current is coming from this side. So you will put battery like this. So plus minus and potential of this battery will be V. This thing we are only doing for your understanding purpose. We are not replacing the wire with the battery. Okay. Okay. So suppose we'll solve a simple numerical that we have a battery of 20 volt. There is a wire AB of resistance 10 ohm and length 10 meter. Okay. So now what we have to do is we have to find out VCM for this wire. So what we'll do is we'll first use Ohm's law, that is V equal to I into R. So I will be equal to V by R. So V is 20 volt, resistance is 10 ohm, so current is 2 ampere. So potential drop in this, so first you have to find out the current, then you have to find the potential drop. So potential drop in AB will be I into R, that is 2 into 10, that is 20 volt, and VCM will be V by L. Okay, this L is in centimeter, so you have to take this L is in centimeter. So length is 10 centimeter. So potential drop divided by length. So potential drop is 20 volt, length is 10 centimeter. It comes out to be 2 volt per centimeter. It means, what it means is that on every 1 centimeter of this wire, the potential drop is 2 volt. Okay, we'll solve some more complex numericals such as like this. So in this circuit, if you'll see, in this circuit, you have to find out. So there's a battery of 20 volt, resistance of 10 ohm, and there are two wires, AB and BC. If RAB is 5 ohm and length of AB is given to be 50 centimeter, RBC is 5 ohm, so BC is 5 ohm, length of BC is 100 centimeter. You have to find out VCM for both AB and BC. So you have to find out VCM for AB cross section and also for BC length of wire. So first step is R equivalent. So what will be the equivalent resistance of this circuit? If you will see, this AB, BC and 10 ohm, all three are connected in series. So R equivalent is 10 ohm plus 5 ohm plus 5 ohm, it comes out to be 20 ohm. Now what we'll do is we'll calculate current. So current is basically V upon R equivalent. So current released by battery is equal to potential of battery divided by equivalent resistance. So potential is 20 volt, equivalent is 20 ohm. So current is 1 ampere. Now what we'll do is, now if you'll see, so from battery, basically 1 ampere current will move. It will move like this, 1 ampere. So in AB the current will be 1 ampere. In BC also the current will be 1 ampere. And in this 10 ohm also the current will be 1 ampere. So first thing we'll find out is what will be the potential drop in AB. So potential drop in AB will be equal to current into resistance of AB. So current is 1, resistance is 5. So potential drop in AB is 5 volt. Now what is VCM for AB? So potential drop per unit length in AB will be equal to potential drop divided by length, that is 5 upon 50, that is 1 upon 10 volt per centimeter. Similarly for BC wire, So potential drop in BC will be equal to current into resistance of BC. So current is 1 ampere, resistance is 5 ohm. So it's 5 volt. But in this case, so VCM for BC will be potential drop divided by length. Potential drop is 5 but length is 100. So VCM for BC will be 0.05 volt per centimeter. So you have to remember how to calculate VCM. So first step is R equivalent, second step is current, third step is potential drop, and fourth step is VCM. We'll solve one more numerical. It will be a tricky one. Okay, so in this type of questions, if you'll see, we have a 50 watt battery, a 10 ohm resistor, and a 10 volt battery up there, a 2 ohm resistor with 10 volt battery, and this connection is made 40 centimeter from A. So we have to find out current in this 10 ohm resistor. What we'll do is we will use unitary method to find out resistance of this 40 centimeter. So for 100 centimeter resistance is 30 ohm, for 130 by 100, and for 40 centimeter 30 by 100 into 40. So it will come out to be 12 ohm. So what we'll do is we'll replace this 40 centimeter with a resistance of 12 ohm. So 30 minus 12 remaining will be 18 ohm on this side. Now what we'll do is we'll put Kirchhoff equations here. So current I is released from battery, it will reach at this point. I1 will go in the upper branch, I minus I1 will in lower branch. At this point again both current will meet and the current will become I, and this I will again reach to the battery. So we'll take two loops. One loop will be A, B, so A, B, C, F, G, H, A. So in this loop, if you put equation from A to B, we have nothing. From B to C, we have nothing. From C to F, we'll put minus 12I minus I1. From F to G, we'll put minus 18I. From G to H, we have nothing. From H to A, we will again have minus 10I plus 50 equal to 0. Another loop that we'll take is C, D, E, F, C. From C to D, we have nothing. From D to E, will write minus 2I1 because current in this 2 ohm is I1. And for this 12 ohm, we'll write plus 12I minus I1 equal to 0 because we are going from F to C and current is coming from C to F. So solving these two equations, you will get value of I and I1. So on the basis of today's lecture, you have to submit 3 or 4 questions that I'm sending it to you. So clear this concept of VCM, then only we can move to potentiometer. Okay, if you have any doubt, you can send me on WhatsApp. Okay, bye bye.